Now, yesterday we have discussed some primary operations, okay, like addition, delete, deleting the vertex and edge, adding the vertex and edge, okay, and also we have discussed the union and intersection of two graphs, okay. Now we have another operation, that one is ring sum. Ring sum. Okay, so what's the ring sum? Suppose we have two graphs, let G1 and G2 are two graphs. Okay, then the ring sum is denoted by this sign. It is the meaning that the ring sum of G1 and G2, if it is a graph G, then the number of vertices of G will be equal to the number of vertices of G will be equal to the number of vertices in G1, means not number of vertices, okay, vertex set will be here. It is the meaning of vertex set, okay. The vertex set of G will be equal to the union of vertex set of G1 and vertex set of G2, okay, and the edge set of G will be equal to the union of their edge set of G1 union EG2, and also we have to we will not take those A's who are in common. Okay, the meaning of this statements, this mathematical notation is that A's that are either in G1 or G2, but not in both. Okay, and you know the meaning of union. Union means just union of VG1 and VG2 sets. Okay, now this definition will be
लास्ट
clear from the
सर
example. Yes.
सर लास्ट लाइन को जरा सा बोल दीजिएगा एक बार।
Okay, wait. I'm saying that just
P of G, P
it
of
is the
G.
set of vertices, okay, and this represent that you will take only those A's which are either in G1 graph or G2 graph, but you will not take those graphs which are both in G1 and G2. Okay. Okay. Now you will got it by taking one example. Suppose I have a graph G1 here. Suppose just take okay, simple. I take this graph here. Okay, this is V1, V2 and V3, and is E1 and age E2. Suppose this is G1 graph. Okay, and suppose again I take here first one, I am taking here V3 and V4. Okay, this is first case, and again I am taking another graph V4 and V5. Okay, this is G3 graph. Now we have to find ring sum G1 and G2. So according to definition of ring sum, vertex set of G will be the union of both G1 and G2. Okay, so here V1, V2, V3, and suppose I take V4 here. V1, V2, V3, and V4. Okay, vertex set is here, this one, and A set, you will take only those A's of G1 or in G2, but not common. So tell me which A's are in common in these two. Is there any A's which is common in G1 and G2?
No, sir.
No. So it means that that graph will be the ring sum of this one. Okay, and suppose if I take here in place of V5, I write here V4. No, it is V5. Okay, I write here V1 and V2. Okay, now what is the ring sum of G1 plus G3? Union, union will be the union represent the number of vertices in G1 and G3. Okay, these are three because V1, V2, V3, here V1 and V2. V1, V2 and V3. Okay, and you will take only those A's which are in either G1 and either in G3 but not common. So in this case you can see that age this one, this is the age V1 and V2, V1 and V2, it is basically represented by 2. Okay, got it? So you will not take this age E3. Okay, and which age you will take? Only E1. E1 is V2, V3. So this one is the ring sum of G1 and G3. Got it?
Yes, sir.
Okay. Now, come to the next definition. Age complement. Age complement. What is the age complement? Okay. The age complement of a simple graph. So first of conditions that let G be a simple graph. Okay, then the age complement of a simple graph G, which is represented by G bar. It is the age complement. This notation is the age complement of G. Okay, it is the age complement of G is such that, okay, so this G has, so what are the vertex set of G bar? Okay, what is the vertex set and what is the edge set? This is the question. If you know the vertex set and edge set, then you can easily define the graph. Is it okay? If you
Yes,
know
sir.
vertex, and because graph is nothing, it is a set of edge and vertices. If you know set of vertices and set of edge, then you can easily define, you can easily create, you can easily draw a graph. Okay, so we have to know about the vertex set of G bar and edge set of G bar. Okay, so what are those? So it means that G bar has the same vertices as Z. It means that V Z bar is equal to the VZ. Got it? And what is the edge set of Z bar? Okay, so means UV, basically it is represented the edge. UV is an edge of Z bar. Condition is here, if and only if this is the edge of this bar, if and only if it is not an edge of Z. Got it? I am saying that you will take those edges, means you can take those edges in G bar which are not in G. Okay, so you will cut the definition by an example. Okay, suppose, so first of all, tell me, is it simple graph?
Yes, sir.
Okay, it is simple graph. So what is the G prime? So G prime means number of vertices will be 5 according to our definitions. Here V1, V2, V3 and V4 and V5. Okay, according to definition, number of vertices in V bar is equal to number of vertices in V. So there are 5 vertices in this, there are also 5 vertices in this, and you can write here V1, V2, V3, V4 and V5. Is it okay? Now
Okay.
you have to find edge. UV is an edge of G bar if and only if it is not the edge of G. So it means that I cannot join this edge. Okay, so what I will do, I will do that. Are you getting?
Yes, sir.
Now okay, it is G bar, and you can see that if you take any edge, means V1 and V3 is G bar, V1 and V3, but V1 and V3 is not G. Okay, same here, v1 v4 in G, but v1 v4 is not in G bar. Okay.
Yes, sir.
Yes.
Yes,
Okay,
sir.
now one more question. When I was discussing the what is the complete graph, so I have denoted that complete graph, I have denoted this notation. So what is this? It is the empty graph. Okay, it was
Yes,
empty.
sir. Yes, sir.
Yes, sir.
Empathy. Complete.
Okay, so again, suppose I have K2. It is K2,
Yes, sir.
Yes, sir.
not even K2. I take K3. It will be more general. Okay, here V1, V2, and V3. It is complete graph with 3 vertices K3. So what is the K prime? K3 prime? Sorry, not prime, bar. Because the
Sir,
number of
only V1 with
vertices will be 3.
Yes, sir. Not
Okay,
any edges.
and we cannot join any edge, because if we join, then edge will be in K3. Okay, due to the completeness. Due to the completeness of K3, we cannot join any edge to these vertices. Okay, so what is this? This is empty graph. Okay, so it means that Kn is the empty graph when Kn is a complete graph. Are you getting my point?
Yes, sir.
Okay, next
Yes.
we move to next definition. Okay, because it is a graph theory, so lot of definitions are in the graph theory. Okay. Okay, I have missed one point in here. Okay, I am emphasize here. This is the age complement. Okay. Next, I am discussing complement of a subgraph. Complement of a subgraph. Okay, so I leave this for you. Just I will explain this one. Okay, I have a graph, this one. Again, I think I am taking this one. Again, this is V1, this is V2, this is V3. Okay, and it is E1, it is E2, and E3. It is K3 graph. Okay, and suppose I have a graph, this one, it is nothing, it is P2 graph which has V1 and V2 and E1. Then find complete graph, because complete of a subgraph. So it is clear that P2 is a subset of K3. It means that P2 is a subgraph of K3. That is, P2 is a subgraph of K3. Then find, then what is the P2 complement? Okay, you have 5 minutes to tell me what is the P2 bar.
sir एज हट जाएगा उनके
V1, V2, V3 वर्टेक्स रहेंगे और E2, E3 एज रहेंगे सर.
सर ओनली V1 V2 रहेगा वर्टिसेस एंड एज नहीं रहेगा।
ओनली V1 V2 वर्टिसेस, V3 वर्टिसेस नहीं रहेगा।
नहीं सर, ये सब ग्राफ है, V1 और V2 ही है ना इसमें।
यस,
तो P2 का अगर कॉम्प्लीमेंट निकालेंगे तो बस एज हटा देंगे और वर्टिसेस रहेगा।
I am, are you getting my point? I am talking about the complement of a subgraph with respect to K3.
सर V1 V2 V3 तीनों वर्टेक्स रहेंगे और E2 और E3 एज भी रहेंगे।
Yes, you are saying that 3 vertices will be here and
E2 और
E2 और
E3
E3 दो
एज
एज
भी
रहेंगे।
रहेगा।
E2 and
E3
E3. Okay. Is it right?
Yes, sir.
Got it? Just you can say that here number of vertices will be equal to number of vertices of this. Got it? And according to definition, complement. UV is an age of Brime if it is not V3. Okay, I think it is clear here. Okay, I have taken only those A's of these which are not in P2. Got it? Even is not here. Okay, just I have a more general definitions. We can say that if G is a subgraph of capital G, then complement of G will be equal to basically Z minus G, and it is nothing. It is the ring sum of G and G. Basically, it is the delete of age. This notation is the delete of age from G. Got it? And this
Yes, sir.
notation is nothing. It is the ring sum of G and capital G. And also you can verify these concept taking these two example and any others. Okay?
Yes, sir.
Next, we are coming to the decomposition of a graph. Decomposition of a graph. So here, decompose means just we can break a graph into two or more than two graphs. Okay, so basically if a graph G is said to have been decomposed, okay, a graph G said to have been decomposed into two graphs G1 and Z2, okay, if the union of G1 and G2 is equal to capital Z, and intersection must be null graph. Got it? Okay, and in the graph G we will disregarded the isolated vertex. Okay, means just we will consider only connected graph. For example, again this is C4 graph. Find two decomposed graph.
सर V1 V2 V3 एक ले लेंगे और एक V1 V4 V3
V1,
V2 V3
V1, V2, V3.
एंड सेकेंड हो जाएगा V1 V4 V3
This is small g1. And second one is
V1 V4
V1.
V3
Okay. So this is V1. This is E3. This is E4. Okay. So union will be the graph G. And intersection. Intersection means there is no common. Now, if you take the intersection of these, null graph will be contain only set of vertices.
Yes, sir.
Because this K3 is common here. This one, these two are common vertices. Okay.
Yes, sir.
Okay. Suppose a graph has m is, okay, then that graph, there are lot of a way to decompose a graph into two pair of distinct vertices. Got it? Means this graph can be decomposed into two subgraphs. There are lot of ways. Got it? This is the one way only. Okay. This one and this one, this one and this one, this one also you can take this one like this one. Okay. So total number of way to decompose a graph will be equal to 2 the power m minus 1 minus 1. For example, in this graph there are 4 vertices, so it means 2 the power 3 minus 1, 7 ways. Okay, now try to decompose this graph to decompose two pair of graphs, and there are 7 ways to decompose this graph into the pair of subgraphs G1 and G2. Got it?
yes
Now, join.
सर m यहाँ क्या होगा सर?
Number of age. Number of age.
Okay,
I'm saying number of age. Join, or we can say suspension. Let G1 and Z2 are two graphs, then their join means addition. to VG1?
No, sir.
Hello?
सर
सर
स्क्रीन
आपका
विजिबल नहीं है,
कॉल
आप डिस्कनेक्ट हो गए थे कुछ देर के लिए।
डिस्कनेक्ट कहाँ, हम तो रेगुलर हैं,
नहीं सर,
कनेक्ट है।
नेटवर्क से ये हो गया होगा आपका
शो नहीं
सर।
हो रहा हम लोगों पे।
ओके, अभी
स्लाइड में
विजिबल
भी
है,
आवाज
स्लाइड
नो
विजिबल है?
सर, नो
नो
सर।
सर, नो सर।
अभी विजिबल है सर।
ओके,
Yes, sir.
ओके। You will be vertex set of here and V will be the vertex set in VG2 set. Okay, so these are the conditions. Okay, it means that suppose G1 and G2 are two graphs, then their sum or join, it is denoted by G1 plus G2, whose vertex set will be the union of these two sets, and edge set will be follow this rule, where EG1 union EG2, got it, and union of those is whose one endpoint in VG1 set and others endpoint in VG2 set. Okay, so you will cut the definition by example. Got it. Now, suppose I have a graph, this one. And again, I have a graph, this one. This is G1. This is G2. So, number of vertices will be 1, 2, 3. Here, suppose it is V1, V2, V3, U1, U2. Okay, now vertex set will be the union of these two, and it means that union will be the equal to number of vertices here in G1 and G2. Total number of vertices will be 5. And A set, you will take the union of G1 and G2. Union means all the A's like this way. Okay, now this A's, we can join the A's, this to this, because one endpoint in V1 and other endpoint in V2. Same here. This is joined to this. Okay.
Yes sir.
This is the join. And next definition is,
सर
yes,
सर अगर V1 V2 के बीच में अगर कोई एज ना होता तो फिर जो नया फिर ज्वाइंट हम लोग करते तो फिर इसमें भी V1 एंड V2 के बीच में कोई एज नहीं होता फिर
V1 से
V2 के बीच में वर्टेक्स हमारा V1 V2
V1 V2, हाँ एज है ऑलरेडी ना, तो यूनियन तो लिया है ना।
सर अगर वहां पे एज अगर नहीं अवेलेबल होता तो फिर इस नए ग्राफ में भी
अगर
नहीं
यस
होता।
आप यदि आप कह रहे हैं कि V1 से V2 में एज नहीं होता,
यस सर।
मतलब आपका ये डिस्कनेक्ट ग्राफ होता, आप ये बात ये बोल रहे हैं।
यस सर, यस सर।
हाँ, तो वो क्रॉसपोंडिंग ग्राफ डिस्कनेक्ट ही मिलेगा।
ओके सर।
ओके, क्रॉसपोंडिंग ग्राफ डिस्कनेक्ट ही
सर
मिलेगा।
इसकी पहले वाला स्लाइड दिखाइए, इसमें यू बिलोंग्स टू यू जीवन, ये नहीं समझ में आया सर।
U मीन्स दिस वन द एज। ओके, ये एज है आपकी G की। Okay, so in which these are the end vertices of this edge. So that it means that end vertices of these two, this edge will be means one end point V1 सेट में होगा और अदर्स एंड पॉइंट दूसरे V2 सेट में होगा। देखिए यहाँ यू कैन सी वी आर टॉकिंग अबाउट दिस एज and this is, so its end point in this one graph, okay, and others end point in this graph.
ओके सर।
Okay, Cartesian product. Okay, so what is the Cartesian product, Sam? Here Cartesian product G1 cross, it is denoted by cross of these two sets, G1 cross G2. Okay, Sam, here the vertex set of G will be equal to V1 G1 cross here VZ2, means number of, if you can multiply these two vertices, and edge set will be here. Okay, there is some specific rule to join the edge. What's are E G1? It is the meaning of edge of G1 graph cross vertex set of G2 union vertex set of G1 cross edge set of Z2. Okay, this is the mathematical notation. The meaning of this is that is, we can write here two distinct vertices, two distinct vertices UV and XY. The pair of this means, I am saying that these are vertices here. Okay, because we are taking the Cartesian product, because resulting graph is the product of G1 and G2. Okay, so in this case, this will represent the distinct vertex of G. Got it? Of G1 cross G2. It is clear now? This is the vertex representation, first vertex and second vertex, and these are distinct of graph G1 cross G2 or just G. Clear? Are adjacent, okay, if either first case set U, V, W, and again I have a graph this one whose
सर
vertex
आपका वापस
is X.
डिस्कनेक्ट हो गया था,
यस सर, आप
इसमें शेयर नहीं है।
स्क्रीन भी शेयर नहीं, आप डिस्कनेक्ट हो गए।
डिस्कनेक्ट हो गया।
यस सर,
Yes, sir.
डिस्कनेक्ट होगा, ठीक है आप।